Alright, here we go on our second day of piecewise function graphs. Now number one is a review of what we did in the last video. So I'd like you to pause the video for a minute or two, and I'd like you to try number one on your own. Now let's see if you got the exact same thing that I got. We start by substituting in our -6 into our x. We take our domain, we substitute it in. -4 times a -6 is 24 minus 20 is 4. X is less than -6, so that's going to be an open circle. Less is to the left, and we have a slope of -4. And then for the second piece, we take our -6, substitute it in here. So we have -6 times 4/3 plus 5, which is going to give us a -3. We have a slope of 4/3, and we are going to have a solid dot going to the right because it's equal and greater. So just like in the last video, we start at -6, 4, which is going to be an open circle. We have a slope of -4, which is down 1, 2, 3, 4 to the right. But since we're going left, we need to go backwards, so we go up 4 to the left. Get rid of this dot so we pass the vertical line test when we're done. And you graph this way. Remember, that is a negative slope. I know you think you went up, but read this from left to right again. If we read from left to right, we're here, and then we start dropping. So this does have a negative slope. Then we go to the green piece. -6, -3. We have a solid dot. Our slope is 4/3, so we're going up 4 over 3. We've got another dot. We are supposed to go to the right, so we go to the right, and we're done. So that's a quick recap of our last video. So now we're going to get into graphs that have 3 and even 4 pieces. Now I know what you're thinking, oh my goodness, this is so much harder, but actually the middle pieces are way easier than the end pieces. You already know how to do the difficult part. Don't believe me? Watch. We still start with substituting in our -4. Stick -4 into here. We're going to get a positive 10 minus 5, which is 5. Still a solid dot going left because it's less than left and equal to. We have a slope of -5/2. Then I'm going to skip and go to the last piece really quick for you. We substitute in our 5. 3 times 5 is 15 minus 10 is 5. That's an open circle going to the right with a slope of 3. Now watch the middle. We have 2 parts of the domain. So we substitute the -4 into the x like we do. We get -4 minus 1, which is -5. And we substitute in our second part of the domain. 5 minus 1, so 5 for our x, minus 1 is 4. And look, you have a starting point and an ending point. You don't need to figure out slope. You don't need to figure out if you're going left or right. You're done. You've got your start, you've got your stop, you're finished. The only thing you have to do is say what kind of line it is. So going back to the blue piece. -4, 5. We have a solid dot. We have a slope of down 5 over 2. But we're going left, so you follow this back up. You go up 5 left 2. And we are going to the left point. And you get rid of your dot, so we pass the vertical line test. The middle piece, like I said, it's simple. -4, -5. You've got an open dot. 5, 4, you've got a closed dot, and you just connect the dots and you're done. You have nothing else to do. And then finally we finish with 5, 5, which is an open circle with a slope of 3, so we're going up 3 over 1. Connect the dots, continue your arrow, and you are finished. So the blue and the green piece are the exact same things that we did in the problem before and in the last video. The middle pieces are easy. Just substitute both parts of your domain. You get your start and your stop, and you're done. So number 3, we have horizontal lines again. Remember, without any x's, these are just horizontal lines. So we're just going to go to level 8, and this is when x is less than -7. So this is just open, going to the left at level 8. So we go to -7, we go to level 8, we put a dot, and we go left. Then the next piece, we're going to have a solid dot at -7,6 and an open dot at -3,6 because we're at level 6. They're horizontal lines only. So we have solid at -7,6, open at -3,6, horizontal line, done. Level 3, from -3, so we have a solid dot at -3, an open dot at x equals 0, both at y equals 3. Connect the dot, done. Now the last one, we have level 1 at x equals 0, but it's greater than or equal to, so you have to remember to carry this all the way across. Okay? Here's the last one of the day, graphing wise. Then we have a word problem to talk about. What I would like you to do is I would like you to try this entire problem on your own. Remember, the ends are simple. You've got two middles. All you need to do is substitute both of your domains into the functions and then connect the dots, la 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 la, and you're done with the middle two pieces. So go give it a try real quick. Take your time. Don't rush it. So let's see if you got what I got. You've got a -8, -1 with an open circle going left, and it has a slope of 3/4 for the first one. The middle piece, you have a start of -8, 5 with a solid dot, and you're stopping at -6, 2 with an open dot. Then you're moving to another start and stop, so we have a -6 with a 0, and this is an open. And then we're going to 2, 8, and that is another open. And then finally we're going to finish with another one of those where we need slope. We have 2, substitute the 2 in, we get 9. This is going to be a closed dot going to the right with a slope of -3/2. There's all of your groundwork laid out for you. It takes a little bit of extra time, but it's well worth it. So we go to -8, -1, open with a slope of 3/4 going to the left. So we're going 3/4 left. And then we're going to start at our -8, 5, solid dot, -6, 2, open, connect. Then we're going -6, 0, open to 2, 8, open, connect, done. And then start at 2, 9, slope of -3/2, and go to the right till you're off the graph. And you are finished. Remember that little tip I taught you in video 1. This has a positive slope, so it's going up. Negative slope, so it's going down. Positive slope, so it's going up. Negative slope, so it's going down. And if we read this, this graph's supposed to go up, down, up, down. Does it? Let's check. We're going up, then we're going down, then we're going up, then we're going down. So the slopes match. It doesn't tell you if you're perfect, but it will give you an idea as if you're going in the right directions. Okay, so that one was a little bit tricky, but hopefully you got it. If you got it, and you got this piecewise stuff. Last thing we're going to do is do a piecewise function word problem to give you an idea. So we're going to take some photocopy prices at Dynamite Dittos. And what this says is that they charge you 15 cents per copy from anything less than 25 copies. But we can't go negative, that's why we have the 0 there. And then if you get more than 25 copies, so 26 copies and up to 100, they're going to give you a discount. They're only going to charge you 10 cents per copy. And then we have 7 cents per copy from 101 to 500. And then if you're going to get more than 500 copies, we're saying I'm just going to give you 5 cents per copy. And you know from shopping or going to the store that a lot of times you get bulk rate discounts. That's why we have places like Sam's Club and Costco and stuff. So if we're looking at the function, how much would you pay for 450? Well, to do that, you just go back, think of your domain. 450 lies between 101 and 500, so we're going to substitute it in for 7 cents per copy times 450 copies, and that's going to give us $31.50. So now we're going to sketch the function below. Label the axes and scale the axes. Okay, so here's the thing. When I ask you for a sketch, I'm not asking for perfection, but I better be able to understand what your sketch is trying to tell me. Okay, so we've got to label the axes. So this is the number of copies, and this is our cost. And then we just need to plug in a couple points. Now, to be honest with you, the best way that I can see doing this is just go label or get your start and stop for all of these. So if you get 0 copies, then you're not going to spend any money. But if you go all the way up to the 25 copies, you're going to spend $3.75. So this is 0 or 25 to $3.75. And that's only from here to here. But then think about what's about to happen. At 26 copies, you actually drop down to only $2.60. And that's because once you get to 26 copies, they're only 10 cents a piece. So you wouldn't really want to buy 25 copies. You buy 26 and you get a little bit of a discount per copy. And then that takes you all the way to 100 copies. And that, at 100 copies, that's going to be 10 bucks. Okay? And then at 101 copies, we start our even bigger discount. Now they're only 7 cents a piece. So at 101 copies, that actually drops you back down to only $7.07. But that'll take us all the way to 500 copies, which will only be $35. And we go that way. And finally, we finish with what happens if we have more than 5. So what if we go to 501? So we go to 501 copies. 501 copies times 5 cents a piece is going to drop you all the way back down to $25.05. And then we have that. Now notice we start by going steeper, a little less steep, little less steep, little less steep, because the slope or the cost per copy is getting smaller. So then we go answer this question. Describe why paying for the amount of copies in part A is asking for suckers. So why would you do that? Why would you get ripped off by doing that? Well, because if you want 450 copies, it's going to cost you $31.50. But if you buy 501 copies, it's only going to cost you $25.05. And that's because of the bigger bulk rate discount. Okay? So basically, why pay $31.50 for 450 when you can get 501 for $25.05. Now I know what you're gonna say, recycling and all sorts of stuff, but this problem is just basically talking about the price. I understand it's good not to waste paper, so before you come with that argument, I just want to let you know it's because we're just trying to figure out cost effectiveness. And that takes us down to the very last second. This is Longo, and I'm out. Have a good one.